Hi learners, I am Dr. Vijaya Kumar Gurrala, Faculty of ECE Department, VNR VJEC. Now I am going to discuss about supernode analysis. It's a part of network analysis subject. There we have, everyone knows about the nodal analysis. First we'll discuss about that briefly, the nodal analysis. Then we'll go on to that supernode analysis. The steps involved in the nodal analysis. As everyone knows that nodal analysis, the essential part of the nodal analysis is to, at each node, we have to apply the KCL. So this is the thing. An essential component of nodal analysis is applying KCL at each node. So first, for the given circuit, we should identify the nodes. Out of all the nodes, label one of the node as the reference node. With respect to these nodes, we should calculate the voltages of all the non-reference nodes. And whatever the number of non-reference nodes are there, that many number of equations we will get. Why? Because at every node we will apply a KCL. One equation we will get. By solving these equations, we will able to calculate the node voltages. This is the general procedure. Calculating the nodes, identifying that nodes, reference nodes, non-reference nodes, that voltages, applying KCL at each non-reference node. And here if you observe Ohm's law, use Ohm's law to express the branch currents. How we will apply? As we know the current relation, I equal to V by R. So here what we will apply is V higher minus V lower by that resistance. The node voltage, in between the two node voltage there is a current flow. That current can be calculated by with this formula VH minus VL by R. So that KCLs gives you that equations, and by solving these equations we can able to find the unknown node voltages. This is the general procedure that can be applied for a circuit that doesn't have any voltage sources. No voltage sources. What if the circuit has the voltage sources? So this is the example I have considered. This is the circuit. If you go through that circuit, the circuit has two voltage sources. Here is the one voltage source and here is the another voltage source. So that can be described with the two cases consideration. So what is that case 1? A voltage source is connected between non-reference node, this is the one, and the reference node. Of course, every node voltage is with reference to the reference voltage, reference node only. So here, whenever if you find a voltage source which is placed between a non-reference node and directly that a reference node, there is no need to apply that KCL. As I mentioned that the essential component of the nodal analysis is applying KCL. So here in this case, there is no need to apply a KCL. Directly we can consider this voltage as that node voltage. So this V1 equal to 10 volts. Here I didn't apply any KCL or anything. So this is easy. What about the other case? Look at here. The case 2. A voltage source is presented between two non-reference nodes. So what is the problem occurs whenever we find a voltage source placed between the two non-reference nodes? As I told you that the essential component is to apply that KCL. So can we able to apply a KCL here? Look at this. At V2, I want to apply a node voltage. I want to calculate the node voltage V2. So I have to apply a KCL over there. Look at here. I1 is the current entering into that node. I2 is the current which is leaving the node. And what about that other branch current? Did it mention there? No. What is there? Instead of a current or resistor or something, what is there? Here a voltage source is there. We don't know the current through which that branch. So you can't apply a KCL over there. Or else if you observe that V3 node, at that V3 node can we able to apply a KCL? Let us see. I3 is there which is leaving that node, and I4 which is incoming to that node. And what about this branch current? That is the problem. We can't apply KCL there. So without applying KCL, how we will proceed to the next? So that is what a supernode analysis. With that supernode analysis, we can able to find or determine that unknown voltages, node voltages. How it is, we will see. See, the two non-reference nodes form a generalized node or supernode. So what we will do? A supernode is formed by enclosing, observe this point, enclosing a dependent or independent voltage source connected between the two non-reference nodes. Here enclosing means as simple as you can understand, like you can remove that voltage source or assume that voltage source as 0 volts. What if we assume the two nodes and the two nodes are separated by 0 volts? What will happen if they are separated by the two nodes are separated by 0 volts? Then there is no need to be separate the two nodes. The two are equal itself. That is what we will consider. That is what a supernode. A supernode is formed by enclosing either dependent source or independent source, whatever it is there. We don't have a separate constraints for a dependent source or an independent source. Whatever it is there, if a voltage source is presented between the two non-reference nodes, you just assume it as a 0 voltage source, so that the two nodes are not being separated. The two are equal. The two are same only. And in addition to that, what we will do is, if any elements connected in parallel to it, that will also be neglected. That is what the consideration we will do here in the supernode analysis, enclosing the nodes. So how we do this analysis? After enclosing, you can apply as usual the KCL process. So I'll apply a KCL process here. So if you observe here, the V2 node, V3 node, I'll enclose this. Enclose this means though there exists a 5 volts source, I'll assume it as 0 voltage source. 0 voltage source means what is there? There nothing in between the separation of that V2 and V3. Both are same nodes. So how it looks like? It's look like there is a 2 ohm resistor, and here I have that V2. The same V3 is also the same. Both are same. And from here I have the 8 ohm resistor, and the 6 ohm is there. This is, and one more branch is incoming to this V3. V2 and V3 are same. So it is like this. So this is the 4 ohm resistor. So 4 ohm resistor is connected to a supernode. This is what? A supernode. By enclosing that voltage source, I have formed a supernode. Now at this supernode, you can apply a KCL. So how to apply the KCL? It is a general method. So I1 is entering, and what are entering currents to this supernode? I4 is entering, and the two remaining currents are I2 and I3. So I2 plus I3. So this is how you can write a KCL at supernode. As you know, what is I1? How you calculate I1? I1 is using Ohm's law. So here we have Ohm's law. VH minus VL by R. So with that process, what is I1? I1 equal to V1 minus V2 by 2. Then I4. What is I4? I4 equal to V1 minus V3 by 4. Then what is I2? I2 is flowing from V2 to the reference node, ground. So it is V2, that ground voltage is 0, reference voltage. So V2 by 8. The next is I3. What is I3? I3 equal to V3 by 6. So substitute this I1, I2, I3 in this equation. That gives you one equation. As you already know, V1 equal to 10 volts, and we have got one equation. But how many voltages need to be find out? 1, 2, 3. One is already been, it is there. One equation is there. To get other node voltage, we require one more equation. How we will get that one more equation? That is with this approach. This is the one. So wherever you find the voltage source which is placed between two non-reference voltages, with that you will able to get one more equation. So what is there? This is V2 and this is V3. So here you will apply KVL. How will apply? Minus V2, this is the one, minus V2 plus 5 plus V3 is equal to 0. So it is V2 minus V3 equal to 5. Second equation. Or else just by visual inspection itself, you can able to say this is V2, this is V3 and separated by 5 voltage source. So V2 minus V3 is equal to 5 volts. Now we have one more equation. This equation and with this equation, V2, V3 as unknowns, but V1 we know V1 equal to 10 volts. So with that substitutions, you can get the other two node voltages. So this is how you can able to calculate the unknown node voltages using the super node analysis. That super node analysis occurs whenever you find a voltage source, it is existed between two non-reference nodes. Let's coming to that properties of super node. We'll just, it is like a summarization. So what are the properties of super node? A voltage source inside the super node provides a constant equation needed to solve for the node voltages. After forming a super node, we have applied a KCL. That is fine. But to get the other, for the further calculations, we have calculated that voltages with the help of this application of KVL. How you applied KVL? That KVL equation is provided by this voltage. That is what is given there. The voltage source inside the super node provides a constant equation that is needed to solve for the node voltages. And the super node has no voltages of its own. As we are making this to 0, so it doesn't offer any voltage. That is what it is mentioned there. And the super node requires the application of both KCL and as well as KVL. To do that nodal analysis, the essential thing is application of KCL. But whenever you have a super node problem, you have to apply KCL also. These are the properties of the super node. Let us see one more problem. I'll quickly finish this. See, this is the problem which is given to you. Determine the node voltages. So first what we will do, identify the nodes and label one of the node as the reference node, the other are the non-reference node. For that non-reference nodes, assume the voltages V1, V2 like that, whatever the number of non-reference nodes you have. Let us look at the circuit. This is the circuit we have. So what we have, how many nodes? This is the node, this is the node, and this is a common node. The 3 nodes are there. Out of the 3 nodes, one node should be considered as a reference node. That reference node is obviously it is indicated with a ground. So the reference node is, this is the node. The other 2 non-reference nodes are labeled with the voltages V1, V2. It is there. Now what we will do, the nodal analysis means you have to apply a KCL. Can we able to apply a KCL here? What are the branches associated or the connected with the reference node V1? Look at here. How many number of branches? 1, 2, 3, 4. The 4 branches are connected to that node. So look at that currents. This is the incoming current to that node, 2 amperes. And let us assume this current is I1. What is that? I1 equal to V1 by 2. Next, the other 2 branches. This is the branch and this is the branch. For this branch, we don't know the current. Why? Because there is no resistance or the current. There is a voltage source. That voltage source is presented between the 2 non-reference nodes. So you don't know that current. So you can't apply a KCL over there. And I'm not finding the current for this. Maybe you can say that the current it is V1 minus V2 by 10. But what is the supernode analysis? It is formed by enclosing the dependent or independent voltage sources connected between 2 non-reference nodes and any elements connected in parallel with it. See, so here a voltage source, an element is parallel to be connected with it. So you have to enclose them. And likewise the case for the V2 node also. You can't apply a KCL. So here what is that this current? Assume that this current as I2. So I2 equal to V2 by 4. Now let us do the analysis. I will consider a supernode. That supernode is formed by enclosing the voltage source in between and any element parallel with it. Now these 2 nodes are same. So apply KCL now. Apply a KCL. How it looks like? The node, the supernode. For that supernode, there is a 2 ampere current. Then 2 ohm resistor branch. The current here it is I1. Then the 4 ohm, the current it is I2. Then the 7 ampere current that is leaving. Now apply a KCL. Entering current and the 3 are leaving currents. So it is 2 equal to I1 plus I2 plus 7. So I1 plus I2 equal to minus 5. This is one equation. Now replace these currents using that Ohm's law. I1 can be replaced with V1 by 2 and I2 equal to V2 by 4. So you will get that equation in terms of the node voltages. Now coming to that, with this alone single equation, you can't determine that nodes voltages. So what we will do, we will apply KVL also. So apply KVL. So by visual inspection, this is V1, this is V2, and here it is, we have the 2 volts source. So what you can say, it is V2 minus V1 equal to 2 volts. And this is I1 is V1 by 2 plus I2 is V2 by 4, which is equal to minus 5. So by solving this 1 and 2 equations, 2 unknowns, 2 equations. Simple. By applying simple mathematics, solve these 2 equations and find out the voltages V1 and V2. So this is how you can determine the unknown node voltages whenever you find a voltage source between the 2 non-reference nodes, that is using the supernode analysis. I hope you understand the topic about the supernode analysis. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.